How did you get on with this? Hopefully not too difficult. Let's have a look at an example solution. Here's the code that I've written for this. As you can see, it is not all that much. So even though we're doing something relatively more complex than what we've been doing before, it is not actually that much more code. Okay, so let's step through this. First, up here we have the function declaration, and the one parameter I've called size, the number of rings that we want to have. Then I create my empty maze using this new CSG function here, as we've seen before with the parts of the gear. And then I have a loop. As you might expect, this loop looks slightly different from what we had before. In particular, it doesn't start at 0 and then count up until we reach size, the number of rings we want, but it goes the other way. It starts at size and counts down. This is this layer minus minus here, which similar to layer plus plus, which increments the variable by 1, decrements the variable by 1. Why am I doing it this way? Well, this will become clear later when we're going to do some more sophisticated things, which are actually easier to do if you start generating the maze from the outside. If you have done this the other way around, that is perfectly fine. You might want to switch over at some point, or you can simply take the example code that I have provided for this. Okay, so then what are we going to do after that? Well, we first of all compute this variable I here, and for this we take the layer that we're currently at, multiply that by 3, and add another 3. This is simply to get the dimensions of the ring, so I is going to tell me how I need to move the various pieces around and how large the cylinders, the rings that I'm going to generate are going to be. That is simply because the layer only increments by 1, or rather decrements by 1 in this case, but we probably want more than a difference of 1 between these layers, so that we can actually, for example, put a marble into this maze and move it around. Okay, what am I doing next? I am creating an opening, and this looks like a lot to start with. So let's take this apart. Let's take this piece by piece. I'm generating a cube here, and this cube has fixed dimensions. This is what we're going to use to cut out a piece of the ring. Always going to be the same size, therefore the dimension of this doesn't change. May take a little bit of experimentation to get this right, but this should be relatively straightforward. And I've chosen these dimensions such that it is a little bit larger than the opening I want to create in the directions where you can't really see it, so that we get a clean cutout of this. Then I'm going to translate this. I'm simply going to move this around in my coordinate system. The y and z coordinate changes here, these are always going to be the same. The only thing that changes is x. And this is determined by my variable I, which tells me something about how far I am from the distance from the origin of the coordinate system computed up here. Okay, and finally, I simply rotate that shape. This is where the random number generation comes in, and I get this from an interval of 0 to 1 to an interval of 0 to 360 by simply taking that random number and multiplying it by 360, which is of course the full circle. So hopefully relatively straightforward. This gives me an opening. I do the same thing for a block down here. We will talk about this condition in a little bit. What happens for the block is essentially the same, except that my cube has slightly different dimensions. We don't want this to be a cutout. This is something that's going to be added, and I have adjusted the dimensions accordingly. Apart from that, this is pretty much the same thing. Now, we have a condition here that checks if the current layer is greater than 1, and only if that is the case, it creates this block. Why are we doing that? Well, essentially, we have 5 rings in this particular example here, but we only have 4 blocks. 1, 2, 3, and 4. One going from the previous ring to the next ring. This is also called the fence post problem. If you have a certain number of fence posts and you want to, for example, put some wire in between them, how much wire do you need? You don't need the distance between the fence posts multiplied by the number of fence posts, but multiplied by the number of fence posts minus 1. Similarly here, we don't want any block, for example, on the outside here. That's not going to be useful. Similarly, we don't want anything extending into the center. That's why we have this conditional here. Otherwise, we would be, if we didn't have this, then we would have a block protruding into the center here. Let me just very quickly show you this. Commenting out the condition, and there we go. Now we have this thing protruding into the center. As I said before, because we are generating random numbers, the blocks and the openings are now in different positions. Okay, let me turn this back on and get a different maze again. So every time I run this using Shift Enter, I'm getting a different maze here because I'm generating different random numbers. And to create the maze, all we have to do is a bunch of union and difference operators. I am taking the difference of a cylinder of radius I and a cylinder of radius I minus 1. This is to create the ring. Works exactly the same way as we did it for the gears. And I'm also subtracting the opening that we have created up here so that we get these gaps in these rings there. And then I'm taking the union of whatever the maze was previously. Remember, we set this up as an empty shape up here, and in each iteration of the layer, we're adding to it, but I'm also adding the block to it that I have created up here. And then finally, I just need to return the maze, and in my main function, now all I need to do is call the maze function. And again, as we have seen before, this is now a function, so I can change this very easily. If I wanted to have 10 rings instead of 5, all I need to do is change this from a 5 to a 10. And now we have something that looks much, much larger. So very easy to play around with this. Again, you can reuse this function. You could now generate a second maze as well. Hopefully you got something similar to this. If not, don't worry about it. You can work with the code that I have provided as an example solution here.